Hi all, today we are going to discuss about our next topic, electrochemistry. So, electrochemistry is the study of chemical reactions which takes place at the interface of an electrode. An electrode is usually a solid metal or a semiconductor and an ionic conductor. This ionic conductor is otherwise called a electrolyte. That is, usually chemists or chemistry people are more interested in electrolytes than the metallic conductors. So, electrochemistry is the study of relationships between electricity and chemical reactions. It is the branch of chemistry that deals with the interconversion of electrical energy and chemical energy. While discussing the electricity or electrochemistry, we have to mention the words insulators and conductors. A substance that allows an electric current to flow through it is called a conductor, and any substance that does not allow any electric current to flow through it is called a insulator. Now here we are dealing with the flow of current or flow of electricity. So insulators have no importance here. So we are considering the conductors only. So conductors can be divided into two. They are electronic conductors or metallic conductor and electrolytic conductors or ionic conductors. So first one is the electronic conductor or metallic conductor. These are the substances that allow the passage of electricity through them without undergoing any chemical change, and in which the flow of electricity is due to the flow of electrons. Thus, any appreciable movement of matter does not accompany the flow of electricity in these materials. Examples are metals, alloys, graphite, etc. അതായത് ഇത്തരം കണ്ടക്ടേഴ്സിലൂടെ ഇലക്ട്രിസിറ്റി പാസ് ചെയ്യുന്ന സമയത്ത് അതിന് കെമിക്കൽ ചേഞ്ചസ് ആ സബ്സ്റ്റൻസിന് കെമിക്കൽ ചേഞ്ച് ഒന്നും ഉണ്ടാവില്ല. ഇവിടെ കറണ്ട് ഫ്ലോ ചെയ്യുന്നത് ഈസ് ഡ്യൂ ടു ദ ഫ്ലോ ഓഫ് ഇലക്ട്രോൺസിൻ്റെ മൂവ്മെൻറ്റ് കാരണമാണ് ഇലക്ട്രിസിറ്റി ഫ്ലോ ചെയ്യുന്നത്. Next type of conductors are electrolytic conductors or ionic conductors. ഇത്തരം കണ്ടക്ടേഴ്സിനെ കുറിച്ചാണ് ഈ ചാപ്റ്ററിൽ ഇനി കൂടുതലായിട്ട് നമ്മൾ ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത്. So, thus electrolytic conductors are substances that allow the passage of electricity through their molten state or their aqueous solutions, and they undergo chemical decomposition at the same time. While passing the electricity, these substances undergo decomposition. They are also called electrolytes. Here, the flow of electricity is due to the flow of ions that is produced by the dissociation of these substances. Thus, there is an appreciable movement of matter during the passage of electricity. And examples for this type of conductors are acids, bases and salts. Here the main differences between the electronic conduction and electrolytic conduction are listed. Let's see. The first one is the flow of electricity is due to flow of electrons in electronic conduction. And in electrolytic conduction, the flow of electricity is due to the flow of ions. The second difference is that in electronic conduction, it does not involve any permanent chemical change. In electrolytic conduction, there is a decomposition of substances. Third one is the electronic conduction does not involve any transfer of matter, but electrolytic conduction involves transfer of matter. Then fourth difference is that the resistance to conduction increase with the increase in temperature in electronic conduction, but the resistance to conduction decreases with increase in temperature in electrolytic conduction. These are the four main differences between electronic conductions and electrolytic conduction. We have discussed that in electrolytic conduction, the substance undergo decomposition, and this process is called electrolysis. That is, the chemical decomposition brought about by the passage of electricity through an electrolyte in the molten state or in aqueous solution is known as electrolysis. Now, the electrolysis is carried out in a apparatus known as electrolytic cell. An electrolytic cell consists of two metal strips called electrodes. Usually, graphites are used. Thus, metallic strips or electrodes are inserted into the molten electrolyte or the electrolytic solution, and it is connected to terminals of an EMF source like a battery. This applied EMF causes a migration of the negative ions, that is the anodes, towards the positive electrode. Positive electrodes are called anode, and that of the positive ions, that are cations, migrate towards the negative electrode, and negative electrodes are called cathode. This battery also functions to cause a movement of electrons from the anode to cathode through the external connecting wire. A schematic diagram of the electrochemical cell is represented here. So, when the anions reach the anode, they are discharged through electron removal. Electrons are removed and they get oxidized, liberating neutral atoms. So, they are groups at the anode. And when cations are reach the cathode, they are neutralized through electron addition, or they receives electrons, and that is they undergo reduction. So, oxidation takes place at anode and reduction takes place at cathode. Now, we can consider the electrolysis of molten sodium chloride using platinum electrode. That is, platinum is inert electron. That is, when molten sodium chloride is electrolyzed using platinum electrodes, chlorine will liberate at the anode and sodium will be discharged at the cathode. That is, chlorine undergo oxidation and sodium undergo reduction. Here is the equations. Cl minus gives half Cl2 plus electron. That is, Cl minus is the anion. It moves towards the anode and an electron is removed, and this electron is passed through external circuit and it reaches the cathode. The cation Na plus receives that electron to undergo reduction to form sodium metal. Here in the first set of equations, there is a correction. There will be only one electron. That is, at anode, Cl minus gives half Cl2 plus 1 electron. The 2 is by mistake I have given 2. So, now let's discuss the electrolysis of aqueous sodium chloride solution, sodium chloride in water, using platinum electrodes. It yields the chlorine at the anode as before, but at the cathode hydrogen will be liberated. This is because water gets reduced in preference to Na plus. In aqueous solution, there are water molecules and sodium chloride molecules, Na plus and Cl minus ions. So, at anode, chlorine discharge, but at the cathode, water get reduced in preference to Na plus ions. So, hydrogen is liberated at the cathode. That is the difference between the electrolysis of molten sodium chloride and aqueous sodium chloride solution. Here is the equations. At anode, Cl minus give half Cl2 plus electron, and at cathode, water plus electron give half H2. plus OH minus. In water, we know that H plus and OH minus. So this H plus receives the electrons removed by chlorine and it liberated as hydrogen gas. So oxidation at anode and reduction at cathode. Now remember that the prediction of the products of electrolysis of an electrolytic solution require consideration of several factors such as the potential at which the competing species are discharged at the electrode, whether the electrode used are reacting or inert, that is whether the electrodes themselves will participate in the electrode reaction or not, etc. Also, as shown in the example of sodium chloride, during the electrolysis of certain aqueous solution of electrolytes, water may be involved in the electrode reaction rather than the ions derived from the solute. Hence, the current carrying ions from the electrolytes are not necessarily discharged at the electrode. Current carry ചെയ്യുന്ന ions തന്നെ respective electrodes discharge ചെയ്യണമെന്ന് ഇല്ല. So here this table shows the cathodic and anodic reactions involved in the electrolysis of certain aqueous solutions of some salts. അതായത് ഇനേർട്ട് ഇലക്ട്രോഡ്സ് ഉപയോഗിക്കുമ്പോഴും ആക്റ്റീവ് ഇനേർട്ട് ഇലക്ട്രോഡ്സ് ഉപയോഗിക്കുമ്പോഴൊക്കെയുള്ള ഡിഫറൻസ് ആനോഡിലും കാഥോഡിലും ഉണ്ടാകുന്ന റിയാക്ഷൻസിലുണ്ടാകുന്ന ഡിഫറൻസ് ഒക്കെയാണ് ഈ കാണിച്ചിരിക്കുന്നത്. താങ്ക് യു.